So good afternoon all. Today we'll be talking about the addressing modes and addressing formats of microcontroller 8051. So this is the prerequisite knowledge which you will require for sharing, handling the various instructions and writing the various programs for your microcontroller 8051. And when we are learning about this, you make sure that you understand these microcontroller addressing modes and formats properly, so that whenever it is required, you need to know how the data is addressed, how the memory data from the memory is addressed, how the data from the input output device is addressed, and the rest of the things. And so accordingly, we can handle the instruction. And into that, we will be writing the program. So this is about the today's session. So when we talk about the addressing modes, basically the definition of addressing mode is the way in which microcontroller handles the information or data from the memory or the peripheral devices. Okay, so addressing modes का data कहाँ से address किया जा रहा है, on that basis the addressing modes are classified as immediate addressing mode, then direct addressing mode, indirect addressing mode, register indirect, then there is a displacement addressing mode and stack related addressing mode. Okay, so we'll see that one by one. This is very important to understand for you also, because when we are writing a program or in the examination point of view also, sometimes the question may come like write a program for addition of two numbers in immediate addressing mode, or they may ask you to write addition of two numbers in the direct addressing mode or indirect addressing mode, so on and so forth. So depending upon how the question is asked, you have to write the instructions accordingly. So for that, what we have to do is we have to make sure that whether whatever instructions we are writing, they are coming from the appropriate addressing modes. Is that clear, students? So let me go for the next thing, next slide. We'll see what are these one by one. So when we are talking about the first addressing mode, that is the immediate addressing mode. In this, now let me explain what is the meaning of operand here. Here the operand ka meaning is a data. Remember, operand is nothing but a user's information or user's data. When that data is a part of instruction, then we call it as the immediate addressing mode. For example, you can see here, this is called as a opcode. This wala part is called as a opcode add, and 5 is the operand. Okay. Now, whenever we are performing any such operations of arithmetical and logical instructions, the result will be always saved into the accumulator register. This is a register. It is also known as A, where your information will be, or the addition will be saved. So for example, if there is a data in accumulator as 05 and we are writing add 05, so both the numbers will be added and the result jo hai, that will be 10 in hexadecimal. It will be saved into the accumulator itself. So this is how, when we are writing the instruction in the two part, one is called as the opcode and another is called as operand. So operand is the data which we are handling and opcode is the task which we are performing. So in this example, this add is nothing but this is opcode and this 5 is nothing but it is the operand. So this is the example where microcontroller has not to fetch any information or data from any other devices, from external devices or from the memory. And this data is directly been transferred, processed or modified, added, subtracted, whatever instruction we are doing. So as per that, microcontroller will perform that operation within its internal registers only. Therefore, the speed of operation of this is very fast as compared to other operating modes. So this is all about the immediate addressing mode. I hope this up to this point it is clear. The next addressing mode is a direct addressing mode. Now let me go back to the previous discussion. Here we have seen the types of addressing mode. We have already seen the types of addressing modes. In that I have told you the addressing modes which are used in the direct or indirect these two, direct and indirect addressing mode, they are related with the memory. So these addressing modes are related with the memory. Okay. So memory से data अगर microcontroller is handling, then we call it as a direct or indirect. Now, what is the difference between this direct and indirect? So in case of direct addressing mode, the data will be always the address of the memory will be available inside the instruction. Okay. But in case of indirect addressing mode, the address will not be specified directly, but it is indexed through some other register. So we can see here, students, address fields can contain the address of operand, effective address. Okay, that address is called as the effective memory address. So whenever in the instruction we are talking about the address, that will be always the address of either input output devices, or the address will be of either the memory address. Okay, so add the contents. Now here what we are using this address for reference as single memory reference to access the data, no additional calculations to work out for calculation of the effective address. So in that, effective address will be directly calculated without any manipulations or any other thing. So here, as I told you, instruction will be consisting of two types, opcode and address. What was in the case of immediate addressing mode? There was opcode, and here directly that was a data. Now in case when our data is present inside the memory, the instruction will be comprising of opcode and the address of that memory location where your operand is located. Now this operand, as I have already told you, this operand is nothing but user ka data. So in this way, so this is nothing but the data where it is located inside the memory. So this type of addressing mode, where address is directly given in the part of instruction or the part of instruction, is called as the direct addressing mode. So I hope this instruction will be either containing the address of memory or the input output device. So depending upon the length of address, the size of instruction also may get varied. If the address is 16-bit, instruction size will be 3 bytes. If the address is of 8 bits, then the total instruction size will be 2 bytes. The next addressing mode is called as an indirect addressing mode. Now in this addressing mode, the address where data or operand is located, that address will be given by a pointer. So in case of direct addressing mode, the address was directly mentioned in the instruction. But in case of indirect addressing mode, the address will not be given through the instruction itself, but the effective address will be given into particular register. So here we can see that effective address is given in by the A register. So this A register will have the address from where the operand is located. So example, we understand this with the example, add A. So in that, the contents of, here we are performing the operation of addition. We are adding the number, and from where we are adding the number, now this A is not the operand. This A is the register which is holding the memory address. So that will be clear into the next slide. So can you see this? So large address, indirect addressing mode mein, we can have large address space, and the effective addresses can be multiplied or manipulated in a multiple memory accesses to find the operand. So this procedure is little bit slower as compared to immediate and direct addressing mode, because microcontroller has to first contact the register where the address is located, and then that address is fetched. And once the address is fetched, then microcontroller will require one more machine cycle for holding the fetching the data. So therefore, indirect addressing mode is little bit slower as compared to other addressing mode. Because why it is slower? Because microcontroller will be needed more machine cycles for fetching the operand. So in this slide, we are just summarizing the effective way. In an effective way, the data is handled by the microcontroller. I'm showing here the 3 examples. This is the first example which I'm showing over here, is a I have written one instruction here called as a move a comma 50. So here, as only 50 is written here, this 50 is becoming the 8-bit address of the destination, and A is the 50 is the effective address of source, and A is the destination. Register A is a destination. So this type of addressing mode is called the direct addressing mode. Second, so how after the execution of this instruction, what will happen? The microcontroller will ultimately copy the contents of memory address 50. I have written here 2C for example, and these will be getting copied inside the accumulator at the end of the instruction. So the data 2C is going to get copied inside the accumulator register. Now, second example I have shown, this is the immediate addressing mode. Here we have to use a hashtag as per the syntax of microcontroller instruction set, and later on we can write down 50. Now the meaning of this hashtag here is simple, means that the whatever number coming after this hashtag will be the directly 8-bit data that is required to be copied inside the accumulator. So after the instruction of this execution of this instruction, the accumulator will directly getting the number which is into accumulator. We are getting, I have written in the bottom also, the direct number 50 will be getting copied inside the accumulator. The data or the source data is directly mentioned in the instruction. So such type of addressing mode, it is an example of immediate addressing mode. And last and very important addressing mode is that I'm writing the instruction here is move R3 comma hashtag 60, and then I'm writing the instruction move capital A, that is accumulator, at the rate R3. Now this addressing mode is typically called as an indirect addressing mode. What happens into this is that here, as the first instruction, we can directly loading the number 60 into R3 register, and later on when we write the instruction move at the rate, now this at the rate indicates the indication of the indirect addressing mode. Now though this 60 has been loaded as a data into the R3 register, once we write at the rate in the instruction to the next instruction, here destination is accumulator and source is the R3 register ka content. Now what is that R3 register ka content? It is 60. Now this 60 is going to become the address of the memory location. So whatever is in the address at the address 60, I'm assuming that data is 0F for example, that data will be getting copied inside the accumulator. So this is just a summary of all the addressing modes: immediate, direct and indirect. I hope this is clear.